My research is looking for new materials, synthesizing them using solid-state synthesis. Idea is that there are a lot of existing materials which people have not been able to improve those, and over time the biggest challenge is that new materials haven't been able to be found. And so our goal is to synthesize new materials which can be used as optical materials, magnetic materials, and for water remediation. So one of the main topics that our group is trying to start is to use AI to discover new materials for water remediation. Manitoba has 5 abandoned mines. One of the biggest problems is these mines are very highly acidic, and northern Manitoba does not have healthcare very easily accessible. The biggest challenge is that these abandoned mines are left and they're very acidic, and as a result these metals exist in water bodies. So over time these metals leach into water bodies, and the first people coming into contact are people around these areas. And so our goal is to really not even have that happen. I'm not saying that there are not existing protocols for this, but we are just trying to add more filters to this particular case. And so this is essentially to remove any of these metals that are stopped at the source at the mine itself and does not expand beyond that. So that is where we are sort of like working at helping Manitobans locally. One of the advantages of having Canada's Research Chair Tier 2 is that I can hire postdocs. So my postdoc, Vidyanshu Mishra, he has experience with machine learning and AI, as well as experimental synthesis, which is a very rare combination to have.
From experimental point of view, I am solid-state materials chemist who design and synthesize new materials. At the same time, I'm using the AI tools to accelerate the discovery of materials. I came up with this idea that we can use the semiconducting materials, which are kind of layered materials, and they can be used to take those toxic elements in their crystal structure or in their structures kind of sandwiched. So we have a material, one layer of material, and then another layer of material, and then in between the toxic metal goes, and then that is get absorbed. So this is the idea that we have been working on, and when we are successful making this kind of material, they'll be used to basically take the metals from those abandoned mines.
We've been able to work on designing new models to be able to predict new compounds. And so through Research Manitoba, our goal was essentially to explore both a combination of AI as well as experimental validation. Our experimental results will act as a tool to iteratively improve the AI model, and eventually over time our long-term goal is that we eventually use this experimental data to improve our models, improve our understanding of how to remove metals from these water bodies. And so we hope that we can eventually come down to a path where a lot of these materials can be used universally as well as locally.